So hello everyone. So today I'll be covering the silent client prop feature introduced as part of this 10.16.2005 release. So I will explain what silent clients are and why they create challenges in our network access environments and how this new silent client prop feature will help address those issues. So with that, let me start the session. So here is the usual agenda. We'll cover the overview, use cases, details and caveats of this feature, configuration, troubleshooting, scalability, followed by a CAN demo, and then additional resources required for this feature. So let's start with the overview. So before we understand the silent client prop feature, we need to know what are silent clients. So silent clients are like non-chatty clients. So they don't regularly send network traffic. You can think of like printers. So printer usually will respond when there is any job request, or badge readers, or certain IoT devices or industrial devices. So these are usually silent devices, which they are not chatty always. And these devices often they enter the power saving modes and they stop communicating, and it makes it harder for our network to even authenticate or even detect them. So this remains a challenge here. The reason being is like most of our security methods, like be it .NX, MacOS, or device profile. So they require at least one packet to be sent from the device to initiate authentication. So when they send that packet, they will use a source MAC address from the packet and then initiate the authentication for those clients. But these silent clients, they never send even one packet. So the ports stay closed and connectivity is prevented. So understanding these device characteristics, so it is very crucial for managing the network access and security effectively. So that is the reason we will see how this new silent client prop feature will help us resolve these challenges. So it's not just this feature introduced will help us manage the silent clients. So we previously relied on several features to manage the silent clients. So I have listed all of those features, and end of the slide deck I have provided references of what are those features, their CLA configurations as well. So let me provide a quick summary of those features here. First is the client inactivity or the idle timeout. So the client inactivity, it is a role configuration. Idle timeout is a radius IETF attributes. So these are applicable to the secure clients. So these clients prevents the already onboarded clients from aging out due to inactivity. Like if there is there is no traffic from the end clients, based on this timers, we can try to retain those clients. But the limitation here is they work only when the client is already onboarded, and the timers will restart after a toggle or switch reboot. So next feature is the allow flood traffic. So this is also applicable to the secure clients. So it is like basically the broadcast and wake on LAN packets to wake up the silent clients. But this is an interface level configuration, and it requires the careful planning of the VLAN configuration. So basically you have to remove the default VLAN one and then configure the broadcast or wake on LAN server VLAN in that interface. So it becomes difficult for colorless deployments, as colorless deployment usually has only default VLAN one. Only for managing these silent clients, we have to modify the VLAN configuration. So next comes the client IP tracker feature. So it uses the R props to keep the clients active. But even here, it is a VLAN level configuration, and it is only effective after the client has onboarded, or at least once the client ARP entry is learned. So it is not suitable for the new clients. So next is the UBT silent client feature. So this is especially for the UBT clients. And the main purpose of this feature is to keep the tunnels active for the VLAN extended UBT clients. So even here, it is not suitable for the newly onboarding clients. It's only for the already onboarded clients. And it requires additional configuration as well, where you have to work along with port access allow for traffic for this feature to manage the UBT silent lines. So in conclusion, So all this feature has specific benefits as well as limitations. So to help us that we need a feature to provide a complete solution like this silent client prop feature. So that is the reason this feature has been introduced in this release. So let's see the overview about this silent client prop feature. So this silent client prop feature lets the switch act as a kind of a server or source of this probe packets. So switch will try to send the probe packets and it will help us faking the silent clients, thereby enabling the authentication. So it eliminates the need for a dedicated device to generate such traffic, like a kind of fake LAN server is not required. We can use switch as the probing device here. And it also reduces the unnecessary broadcast or unknown unicast and multicast traffic. So providing like direct control over the probe types and then the timing of how frequent you wanted to send the probe packets. So administrators can also set what probe packets are sent and how often and under what conditions the probing should stop. So everything is being controlled by this silent client probe feature. So let's see more details about this feature in the upcoming slides. Supported platforms. So here is the list of platforms this feature is supported. So let's move to the use cases section. So I would also call out this use cases as kind of customer benefits, like what is the benefit we will be able to get it if we enable this silent client pro feature. So the first is the efficient activation of silent clients where switch act as a probe source. So the waking the silent clients is efficiently managed by the switch itself without the need for extra devices or servers. The switch will be sending the prop packets to wake up the silent clients. So next is the customizable prop packet configuration. So the prop packets can be customized, be it the type, the frequency, or when the propping has to be stopped based on the client requirements. And also like some of the devices like IoT industrial weighing skills and all. So they require like specific prop type to be sent. Only then those devices will be able to respond properly and then they can wake up. So to help those specific devices also, this feature will really help. Like for the targeted probe data, you can send to those devices and then wake up those devices. So it is kind of flexibility we provide for the specialized devices as well here. So overall, this feature will help the switch to act as a probe device and then flexibility to choose the probe type, be it the configuration of the probe parameters like the interval or the stopping conditions of the probe. So let's see the details about this feature. So this silent client probe feature uses the profile to define the probing parameters. So first is the VLAN. So in which VLAN this probe packet has to be sent, whether the VLAN level this probing has to be enabled or not. And next comes the source MAC, source IP address, and then the destination IP address, be it broadcast IP, directed IP range, or directed IP list. So these options are provided in the Pro profile. So this Pro profile can be the local one where you will have these options available in the CLI, or a remote Pro profile where you can store the Pro profile as a JSON format and then you can download it in the CX switches. So this download is possible via SFTP and then TFTP server currently, and strictly the file format is to be JSON format. So other conditions to be noted here is only one profile time can be active. So either you can use a local profile or a remote profile, not the both of them at the same time. And the probing methods also include periodic probing, like we can set the intervals, or it is based on the client detection. Like once the client is detected, we may stop probing as well. And the probing intervals are like configurable, where you can set between 30 to 300 seconds, and default it has a value of 60 seconds. So it's not just only once the switch will try to get the probe profile from a remote server. So we do have a refresh interval. So we can make sure based on the refresh interval, the switch can try to get the remote JSON file from the remote SFTP or TFTP servers. And in case if there is any error with the recently downloaded remote profile, so we will try to retain the older profile as well. So thereby we have providing a fail-safe mechanism in terms of the remote proof profile. So now let's see the silent client probe attributes. So with respect to the client probe, we do have three main attributes: probe type, probing method, and then probe interval. So what is probe type? Like it is the what type of packets will be used for probing the silent clients. So we do support multiple probing types like ping broadcast, ping unicast, ping sweep, and then the gracious ARP. It's not just only one probe type can be used. You can configure multiple probe types in the client probe profile. Next comes the probing method. So we do have two probing method, periodic and then the client direction. So in the periodic, where you will configure the interval, as I mentioned earlier, it is from where we can have 30 to 300 seconds of probing interval, and default it is 60 seconds. And next comes the client direction. So consider there is a client detected in that port. So we do not want it to send the probing packets because the client is detected. We don't want it to unnecessarily utilize the bandwidth. In that case, we can stop the client probing once the client is detected. So that is the advantage of using the client detection probing method. So now let's see the silent client probe types. So there are, as I mentioned in previous slide, there are four main probe types to use to wake up the silent clients. So we do have ping broadcast. So it targets all the devices in the subnet, and maybe there are certain security-wise restrictions. They may try to block the ping broadcast. So kindly make sure if your silent client device responds to the ping broadcast. Based on that, you can configure this probe type. And we do have ping unicast. So it's like targeting a specific IP address for direct reachability checks. Next comes the ping sweep. So it scans a range of IP addresses. And then we do have the gracious ARP. So it sends gracious ARP request to update the ARP tables and direct devices on the local layer 2 network. So each type serves different operational needs and then network environments. So based on the type of probe type is supported in your client device, you can select them accordingly. So the next topic is about the VLAN filter configuration. So in the client probe profile, we saw the VLAN as one of the attribute. So it mentioned in which VLAN this probe packets has to be sent. So we do have this VLAN filtering feature as part of this silent client probe. So by default, the probe packets will be sent for all VLANs in the profile. Whichever the VLANs you have configured in the profile, all the VLANs the probe packet will send. But if you wanted to filter out it, it can be done using this VLAN filter configuration. So it has two methods. One is the unsecured and then the secure. So what is unsecured? So consider there is no client onboarded in that particular port. So that means the port is not secured by port access. So in that case, we will call it as unsecure. So in that unsecure, we do have two options, port and then all. So what does these options mean? All means when you mention the VLAN filter as unsecure all, when there is no client onboarded in that particular port. So whatever the VLAN that is present in the probe profile, be it local or remote probe profile, all the VLANs this probe packets will be sent. So it is the use case of this all option. So next comes the port option. So you do not wanted all the VLANs probe packets to be sent. Only wanted to send the probe packets to particular VLAN, the port has been marked. Like for example, in the interface level context, default you have mentioned VLAN 1, and you wanted to send probe packets only in default VLAN 1, you can use this port option. But by default, the all option is enabled. So next comes the secure option. So previously we saw when there is no client onboarded, that is handled by the unsecure option. So this secure option handles the cases where the port is secured by port access. That means at least one authenticated client is present in that particular port. So even here we do have two options, all and then the port. So all means like whatever the VLANs that has been configured in the client probe profile, all the VLANs, the probe packets will be sent, and it is the default. And next comes the port option. So here there is a difference in port option from unsecured and then the secure method. So here the port option means consider there is a port level, the default VLAN is 1, and then the client has been onboarded in VLAN 10. So this VLAN 10 where the client is onboarded becomes the MAC based VLAN for that particular port. So only in that VLAN the probe packets will be sent. So thereby we can avoid sending unnecessary probe packets in all the VLANs. Only in which VLAN the client has been onboarded, in that VLAN the probe packets can be sent. So thereby it will help us to retain the clients, even though the client has been already onboarded. So because of any inactivity timeout, the client cannot be deauthenticated. For that reason, we can use this port option. So let's see with an example about this VLAN filter option. So here is my remote probe profile. So I have used a JSON format here. So you will see I have enabled for three VLANs, VLAN 10, 20, and 30, and have configured the source MAC IP and then the destination IP options. So let's see the unsecured configuration. As you see in this slide, you do have three VLANs 10, 20, and 30 in the probe profile. So when you have unsecured and then sub option as all, the client probe packets will be sent in all this VLAN 10, 20, and 30. But when you set the option as port, you need to check what is the port level VLAN configuration. So in that case, in this port, it is VLAN access 30. So the probe packets will be sent only in that VLAN 30. So when you set unsecure all, it will be all VLANs. If it is port, it will be only the port level VLAN. So next is the secure method. So in secure method, what happens is similar to unsecure, when the option is set as all, whatever the VLANs that is configured in the probe profile, all the VLANs, the probe packets will be set. When you set the option as port, so you need to check which is the MBV VLAN for this particular port. So this client, even though the port level VLAN configuration is VLAN access 30, the client has onboarded in this port and it is onboarded in the VLAN 10. So this VLAN 10 becomes the MBV VLAN for this particular port. So the probe packets will be sent only in this VLAN where the client has been successfully onboarded. So this is how this VLAN filter feature works. So let's see the caveats for this feature. The mandatory profile attributes must be set to avoid incomplete entries. In case if there is missing mandatory attributes, you will see like the profile will be incomplete and it will not be used. So as I mentioned previously, only one profile time can be active. Like it is either the local or the remote one. You cannot have both the profiles. And also avoid using identical names for local and remote profiles to prevent like accidental deletion using configuration restores. So for VSX synchronization, ensure like the secondary device ports are layered to maintain the probe functionality. So as I mentioned, we do have this remote refresh interval timer. So how frequent we wanted to get that remote probe profile downloaded from the remote server. So this remote refresh interval like resets after the ISSU. And then one more caveat to be noted here is the downloader remote profiles cannot be modified or deleted on the switch. It is the static only. You cannot on the fly change the downloader remote profiles. So let's see the best practices to be followed for this feature. So the first best practices is ensuring the remote JSON file names. It should conform to the profile naming rules. Like you have to make sure it is 2 to 128 characters post stripping the optional JSON extension. So next is with respect to the VLAN filter, which we saw in detail previously. So it is wise to set the VLAN filter as unsecure all and secure port. The reason is when we mention as unsecure all, so irrespective of the port level VLAN configuration, the probe packets will be sent to all the VLANs configured in the probe profile. So once this configuration is made, it will help us to easily onboard the silent clients. And after the silent client onboarding is successful, we don't want the probe packets to be sent for all the VLANs. We wanted the probe packet to be sent only to the VLAN where the client has already onboarded. For that, we can configure the option as secure port. So thereby, it will avoid the unnecessary probe packets to be sent across the unused VLANs in the probe profile. And it is also good to configure the probe type as client detection. So even here, it will avoid unnecessary packets once the client has been detected. Because the reason for this feature to be helpful for the silent clients wake up is to initial onboarding. So once the client has been onboarded, we not necessarily require the probe packets to be sent, but it is also depends upon the client type as well. Some of the clients they frequently age out. For those clients, we do not recommend this client detection method. And also, if you have multiple silent clients present, this sign client detection method will not help. You have to configure it as a priority. So this client detection can be configured based on the silent client type. And also, as I mentioned, for the ultra silent clients, means the clients will not even send a single packet and they may enter power saving mode. It is wise to configure a periodic mode. So let's move to the configuration section here. First, let's see the remote profile syntax. So this is the file that will be used to generate the probe packets once they are downloaded from the remote location using SFTP or TFTP. So it is a strictly JSON format and it can have multiple entries for each VLAN. So here are the attributes and I have explained the attributes for the particular VLAN profile here. First is the VLAN attribute. Next is the enable one, whether this VLAN is to be enabled or not when we try to download the probe profile. So in case if you wanted to disable a particular VLAN, rather than changing the entire probe profile, you can play on this enable attribute. And next comes the source MAC. The source MAC to use in the probe packets. So if you have not provided the source MAC, the system MAC address will be used in the probe packets. Hence, it is not a mandatory attribute. And the main attribute is the source IP. So you have to configure the source IP to be used in the probe packets. And one major advantage is it is not a IP that should exist in the switch. It is the probe packets generated by the switch. So whatever the IP that is configured in this probe profile will be used. And it is one of the mandatory attribute here. Next comes the destination IPs. It can be either the broadcast IP, directed IP range, or a directed IP less. So this broadcast IP will be used for the probe type ring broadcast. The directed IP range will be used for the ping sweep or the gracious R probe type. Similarly, the directed IP list will be used for the probe typing unicast or the gracious R. So both this directed IP range and IP list currently support a maximum of 255 addresses. So any one of them is a mandatory attribute to be configured in the probe profile. So similar to the remote probe profile, we do have this local probe profile configuration where you can configure the probe parameters for the profile from the CLI itself. So it is the context here, client probe, and then the profile name, and you have to create entry for each VLAN. So similarly, we do have those VLAN, source MAC, source IP, broadcast IP, directed IP range, and directed IP list configurations available. Hence, I'm not explaining those attributes individually. It is the same set of attributes as the remote probe profile. So let's see the global configuration options available for this feature. The first is the client probe configuration context. So here you can either associate a remote probe profile or you can configure a local probe profile. So these are the mutually exclusive ones. Either one of them can be done. So in terms of the remote probe profile, we can associate the profile mentioning the source for downloading the remote probe profile, the SFTP or TFTP server credentials, and then the IP address of the server, port in which you wanted to download, the file path, and then respective VRF. So next, this client probe profile has to be enabled globally. So we do have the enable configuration. Only when it is enabled globally, the feature functionality will be working. And we do have probe duration. It can be periodic or client detection. And probe interval from 30 to 300 seconds, default is 60 seconds. And you can configure the probe types, be it ping broadcast, unicast, ping sweep, or the gracious ARP. So you can have multiple probe types as well. So for the local probe profile configurations, it is a profile configuration context under which you will have those VLAN or the source and destination IP configuration options available. So next comes the remote server refresh interval, the frequency at which you wanted to download or get the latest probe profile from the remote server. So next is the VLAN list filter, where do we have options of unsecure with port and all sub options. So this is the overall global configuration available as part of this client probe profile. So now let's see the other configurations. So, so after enabling the client probe globally, we wanted to control the interface level probing. So this is possible using the interface configuration. You have to go to the particular interface where you wanted to enable the client probe and then do a client probe enable. So as I mentioned, globally has to be enabled, only then the interface level also will be working. So currently this client probe feature is supported on L2 physical and then L2 lag interfaces. And next comes the remote server refresh interval. This is also, you can configure the periodicity when you wanted to get the latest version of the remote probe profile from the remote server. And next comes the forced download of remote profile. In case you do not wanted to wait for the remote refresh interval, so you wanted to uh, forcefully download the remote probe profile, you can initiate it using the client probe profile force download. So here are the sample probe profile configurations. So I have given both the remote probe profile and then the local probe profile. So remote probe profile, so we do have the JSON format with, here the example has for the three VLANs where you can see the source MAC, source IP, and then the destination IP options available. So next comes the local probe profile sample configuration. So you have to go to the client probe configuration context, and then you have to configure the profile with the corresponding name and create entry for each VLAN. So it will be like entry and then the entry number, and then you provide the VLAN source MAC IP and then the destination IP options. So far we have seen the syntax. So I've given the sample probe configuration here. So the first one is the remote probe profile association. So here I have created the client probe configuration context and then associated a remote probe profile using SFTP server with the credentials to reach out the server and then the remote probe profile file. And then you can configure the remote server refresh interval, probe type, probe interval, probe duration, as well as the VLAN list. So once it has been enabled globally, you can enable this client probe functionality in the interface level as well using this client probe enable CLI. So let's see the local probe profile variant here. So similar to the remote probe profile, we do have this client probe configuration context. So where we have the respective parameters of the probe, like probe type, interval, probe duration, VLAN list, and then the local probe profile configuration context where you configure the profile name and then the entries for each VLAN, having the source MAC IP and then the destination IP options. And then we have to enable the client probe in the interface level context as well for the functionality to work. So far, we have seen the CLI options. Next comes the REST one. So for the REST, first we need to create a client probe profile entry. So the entry is where we, for each VLAN, we create the source, IP, MAC, and destination options. So those profile entry has to be created first. So once the entry has been created, you can associate that entry in the client probe profile context here. So it is the option having the entry as well as the name for the probe profile and whether it is a local or a downloaded one. So once you have configured the profile entry as well as the probe profile, next comes the overall global client probe configurations. So those are available in the system level context only. Let's jump into the troubleshooting section here. First, let's see the show and clear commands introduced as part of this feature. So following are the new show commands. Show client probe profile. So it will either list all the probe profiles or you can also use the profile specific show command. And next comes the show client probe statistics. Similar to that, you can see the statistics of all the probe profiles or the for the particular interface or for the all the interfaces. So if you wanted to clear the client probe statistics, you can use the clear client probe statistics for all the interfaces or for the specific interface. So let's see the sample show client probe profile. So I have given both remote and then the local probe. So for the remote probe profile, you will see the type as downloaded, and it will also provide the details of when the last download attempt made and whether that attempt was successful, whether that profile is in use or is there any challenges in using the probe profile. So you will see the entries listed as well in detail. Similarly, for the local probe profile, you will see the type as local and then the profile status, and each of the entries will be displayed. So next comes the show client probe statistics show command. So this statistics command will clearly display the interface level probe packets sent. So all the probe type packets statistics will be visible here. Similar to the CLI show commands, we do have the REST APIs as well. You can use the get of the client probe profile entry to view the profile entries. And to get the client probe profile and probe parameters, you can use the system client probe profiles. where you can also select the additional columns to be used, like client probe type and client probe duration. So next step in troubleshooting is the logs. So to view the event log specific to this silent client probe feature, you can use the show events minus daemon. The daemon here is client probe D. So we do have only this event log supported currently. So in case if there is the remote file is not valid, like the file name is not based on the characters specified, this event log will be displayed. So next step in troubleshooting will be the debug logs. So to view the debug logs for this feature, so you can use the debug client probe all. So once you enable this debug client probe all, you can have the show debug buffer model, and it depends upon the which debug destination you wanted to use, and then the daemon name, that is client probe. It will display all the client probe related debug logs here. So I have given a sample debug logs where there is a parsing error when the probe profile was downloaded. So here is the table representing the CLI warning messages. So as we saw, a lot of caveats are there with respect to the feature configurations. So it's to make the customer aware of those caveats, we have also provided the CLI warning messages. So in case if you try to configure local profile when the remote profile exists, vice versa, you will see those CLI warning messages displayed on the screen. So it will take care about those warning messages, and then based on the warning messages, we can modify the profile configuration. So I've listed all the CLI warning messages supported here. So next comes the scale part. The scale remains the same for all the supported platforms. So the maximum number of client probe entries per profile is 32. It means for we can create probe profiles for 32 VLANs. And maximum number of unicast IPv4 addresses in the directed IP list or IP range will be like 255. So more than that, if you try to configure, the profile will be considered as invalid. So let's move to the demo section. So before I go into the demo, I will just give introduction of what will be covered in the demo. So I have used the access switch 6300 here and have connected a simulated silent client. And I've also provided the configurations used both in the using the local probe profile or the remote probe profile, as well as the remote probe profile syntax in the JSON format. So I do have a silent client connected in the port 1. When it comes to the local probe profile, I have used the probe type as gracious R, ping broadcast, and ping unicast. And then I have given the profile for two VLANs here, VLAN 20 and VLAN 30 with the source IP, and then destination types as directed IP list and then directed IP range. When it comes to remote probe profile, we do have three VLANs entries here, VLAN 10, 20, and 30, and I have configured the source MAC. Previously, the source MAC was not present in the local probe profile. The reason I wanted to use the system MAC. So here I have used the explicitly the source MAC to be used in the probe packets. And then I have given the source IP and then the destination IP formats here. And you can view the statistics of the probe packets using show client probe statistics. So let me share the demo screen. Let me start the demo here. So I have used the access switch and then the silent client screens here. So first let's see the configuration in the access switch. So I have used a 6300 switch and I have configured the local probe. So I have mentioned the probe type as ping sweep and then ping unicast, and then the profiles. I do have two entries, VLAN 20 and then VLAN 30. With the corresponding source IP and then the destination IP probe types. So here is the silent client connected port. I have enabled MAC authentication and then enabled client probe. Currently the port is in shut state. So I'll try to bring up the port as well once the configurations are validated. And for this silent client, I'll be trying to associate the role silent client here. So I wanted to show here the VLAN and then the IP is configured. You would see that VLAN 30 IP address is not present in the switch. It is using the configuration present in the pro profile only. So let me enable the port as well here. So you can use the show client pro profile to view the probe configurations mentioned previously. So let's check the statistics before we start the probing. So here is my simulated silent client. The IP address is 20.1.15 here. So I will run a TCP dump on this silent client. So I will go to the interface context and enable the port. Currently the silent client has not yet onboarded. Now it has onboarded. So let's see the recap of the packet sent. So you will see the ICMP echo request based on the configuration we made it in the local pro profile from the source IP to the destination IP configured, as well as the ICMP echo request for the range of IP address mentioned. So this helped the silent client to onboard and place it in the VLAN 20. So now let's check the profile configuration again. So you will see the source IP and directed IP list as well as the directed IP range here. Let's see the statistics. So the ping unicast was sent based on the directed IP list. It had only one IP, the 20.1.50, and then the list of IP addresses for the VLAN 30. Since it is a periodic probe, so based on the configured probe interval, you will see the ping unicast and then ping sweep then every probe interval. And since it is configured as VLAN filter as unsecure all the default configuration. So whatever is the VLANs configured the probe profile, all the VLANs the probe packets were sent. That is both VLAN 20 and then the VLAN 30. So now I will change it to probe duration as client direction. So let's see the probe packets sent based on it. So you will see the probe packets are not incrementing. It stays in this 333. The reason being is the client has been directed. That's the reason we were not sending the probe packets. So now we'll go to the remote probe profile example. So I've created a remote probe profile in the remote server and then associated it using the SFTP as a method to download it. And I have provided the credential and then the file name. So here I've given the prop type as ARP and then ping broadcast and ping unicast. And I have three VLANs, VLAN 10, 20, and 30. So here is the same interface level configuration. And then the rule is the silent client rule. So let's check the probe profile configuration. So it clearly displays the remote probe profile, whether it has been downloaded, the download status, and when it was downloaded. And here are the list of VLAN that has been used in the remote probe profile. So I have VLAN 10, 20, and 30. For 10, I have source IP and directed IP range. For VLAN 20, I have source MAC source IP and I have using the broadcast IP. For VLAN 30, all the options are enabled when it comes to the destination IP. So let's check the syntax of the remote probe profile JSON. So it uses the same configurations I have mentioned in the slides. First comes the enable, the VLAN, and then source, MAC, and IP options, and then the destination IP options. So let me start the PCAP in the silent client device. So here I wanted to show the source MAC address. Hence I've changed the filter for the TCP dump. So let me start the client here again. So I will go to the interface contact and enable the client connected port. So immediately you will see the probe packet sent. So let's see the recap of those packets. So you see the client has onboarded successfully and been assigned the role. So first in the VLAN 10, so you will see the GAR packets, and next the ping broadcast packet, and you would see the silent client responding to the broadcast ping request. So it helped the wake up the silent client. And also the VLAN 30, we do have the different destination options available. So it had directed IP list range and then the broadcast and then the RPA well. So that's the reason we see all those packets sent in the VLAN 30. So now let's change the client probe configuration. So I'm modifying the VLAN filter in this example. So by default, it is unsecure all and then secure as well as all, but I'm modifying it to secure port. So that means the probe packets will be sent only in the MB VLAN, that is MAC-based VLAN, where the client has onboarded. So you can verify the configuration here in the show run. So let's run the TCP dump again in the silent client and check the probe packets. So the probe packets will be sent only in the particular VLAN the client is onboarded, that is the MAC-based VLAN. Here it is VLAN 20. So only those probe packets will be seen. So thereby it will avoid the unnecessary probe packets that is sent across all the VLANs configured in the probe profile. So with that, I've come to the end of my demo session.